getting stuck. And then who wants to say the 3 hour limit? Who knows what I said in that time, right? I'm gonna sort of talk about what a limit is today, but really Monday we'll do a lot more limits. But we're gonna use instantaneous velocity to help us kind of discover maybe why we need this I think limit. I wrote this. Well, you already know all the math you've ever learned in your life, right? You remember all of it. So when we talk about rates of change, lots of times we just think about slope. But if we talk about movement, hopefully maybe you know that to find the distance traveled, you take your rate times your time. Right? So if you were going 60 miles an hour for 3 hours, you should know how far. If you want to find your average speed, you can take your distance covered, total distance traveled, divided by the time. So if I knew that I traveled 300 miles in 3 hours, so that's pretty fast, that's going, then I could say, oh, I was traveling at an average speed of 100 miles. Really what you're doing when you do average speed, it's like you're picking 2 points and you're kind of finding the slope of that line, and that's what I like about that video. Like if I knew, I forget how they do a picture here, but if I had a point here and a point here where I ended, and I wanted to get the average speed over time, and on the video, he was like, obviously you don't always travel at a constant speed because you have to stop and slow down for different speed limits. But if I wanted to find the average of that, basically it's like the slope. So this is easy to think about the total distance, but you can also think about it as slope. So like if this was x1, y1, and if this was x2, y2, the distance covered is going to be the change in the y's, because that's going to be the vertical change. So that would be like y2 minus y1. And the elapsed time is your x-axis, so that's going to be the difference in your x-coordinate, x2 minus x1. So when you think about average speed, average velocity is kind of like the slope between 2 points that you have. Instantaneous speed is the speed at an exact point. So I would be like, if I traveled for 3 hours, how fast was I going at exactly 1 hour into my trip? It's a little bit harder to think about because you don't have 2 points that you can average. I need to know the exact speed. So what we're going to do is we're going to say, let's look at the average speed over an interval from the time that we want to a time slightly later. And we're going to talk about what does that mean slightly later. And so we're going to talk about this idea of t plus h, where h is a really small number. There's only 2 problems on the notes today. Does that scare you? Only 2 problems. So it says an object is dropped from rest from the top of a tall building and it falls y equals 16 t squared feet in the first t seconds. So notice what they're giving us here. This is like the position function. Because if I plugged in 0 there, I would get 0. If I plugged in 1 there, I would get 16. You with me on that? So like I'm getting the position. I'm not getting the speed. I'm not getting the average speed. I'm getting position. And so I want you to use what we had on the previous page there and find the average speed during the first 3 seconds. So remember that there's 2 ways to think about this. The average speed. One way to think about is distance traveled. I will. Well, I thought that was I scared. And notice we're starting at 0 seconds and ending at 3 seconds. Another way to think about it is to think about it in terms of slope. And so totally like you can figure out how much distance you travel in those 3 seconds and divide by 0 to 3 seconds, which is 3. Because I'm trying to get us to this algebraic part, I want to show the algebra. So we could also write this as the y value. So instead of doing y2 and y1, are you okay if I write f of 3 minus f of 0? Is that the same as the y value at 3 seconds and the y value at 0 seconds? Over the x value, which is 3 minus 0. And again, you don't have to do that on average speed, but I'm trying to help us with this, so that's why I'm doing that for this one. So on this one, I want to know what is its position after 3 seconds. And so I can plug 3 in up here, right? Which is 16 times 3 squared. 16 times 9. And in this case, when we plugged in 0, we get 0, and so if you just would have plugged in 3 seconds, you would have got that it was just 0. I mean, yeah, you would have got 144 divided by 3. And 144 divided by 3 is 8. Notice we are now in speed, and if you're ever confused about your units, the top is my y value, or my distance traveled, which is going to be what I get when I plug in a value. I get feet. So the top value here is feet over time traveled. So the time is the x-coordinate, which is in seconds. And so the average speed for this object during the first 3 seconds is 48 feet. You've done average speed before. It's not really a new concept. Maybe it seems like it's a new concept, but it's not. But what if I asked you to find the exact speed at 4? Not the average speed, but the exact speed. I can't just plug 4 in there because that doesn't give me the speed at 4 seconds. It gives me the height. Like, what am I saying? So this is where we have to use this idea of we need 2 points in order to find the speed here. So we want to look at some time slightly later than 4 seconds. So I'll make a little table here, okay? Let's write my notes here. So our staple out of we have t equals 4. And then we want some time slightly later than 4. Slightly later than 4 seconds. And we're going to call that t plus h. We're going to make a little chart here. This is where you got your calculator. It's going to be nice and figure out that calculator. What's super great about these calculators is you can, like, if you want to reuse the same thing, you can arrow up and hit enter, and it'll pull out the name you go back and the old calculator. Great. I'll pull my calculator over to you. And then we're going to put average speed here. We're going to figure out the function for that. We're going to make a little chart. You don't have to fill up your whole... We're only going to do like 4 numbers, so I don't really need to fill up your whole page. But it's okay, because we can write on the next page. And I think I totally did it. Okay, so T is always going to be 4, because we're trying to find it at 4 seconds. What's sometime later than 4 seconds? 5 seconds. So we could say T plus H is 5 seconds. What would that make the H value? 1. 1 is slightly later, 1 second later. So we could do the average speed, the same thing we did over here, but now we're going to do it between 4 and 5 seconds and see what's the average speed between 4 and 5 seconds. So average speed, we're going to take the f of 5 minus f of 4, the change in the y's, over 5 minus 4. Oh wait, I feel like I need another column here for like the instant. So 5, where f is so we're going to do f of 5, where it's 16 times 5 squared, minus 16 times 4 squared, and 5 minus 1 is just 1. But I can do 16 times 5 squared, minus 16 times 4 squared, so when I divide by 1, I'm just going to get 144 because we're going to get that. Use where I'm getting these numbers from. So if you have room here, you could write it equals over here. But I'm going to, this is 144 feet per second. Could I get closer than 1 second from 4? Is there another number I could pick that would be closer than from 4 to 5? Let's say from 4 to 4.5. Can I do that? Yeah. So let's do it again. So, this would be f of 4.5 minus f of 4 all over 4.5 minus 4. And again, I'm just doing that change in the y's, change in the distance over change in the time that's traveled. And here's what I was trying to tell you about the if you want, it's not going to work, but you can arrow back up here, and you can hit enter. You can hit enter, and then you can go back over and edit. So like if you had a big long thing, you can change the number. If you have if not, you can go back. Because everything else is the same. But then don't forget that I have to divide by 4.5 minus 4, which means I'll be dividing by half here. Okay? And I want to get even closer. What if I did 4.1 seconds? And I'm going to go ahead and say I also want you to do 4.01, because that would be even closer, right? From 4 to 4.1 seconds, and 4 to 4.01 seconds. And see if you notice. I kind of skipped this before this easy. What? I wish we had 130. So with 4.1, I got 129.6. Did you get that? Did you do the other one already? 4.01, what did you get? 128. 128.16. Could we even get closer to 4 seconds? We could. I won't make you do this one. I'll just look at it. I did 4.001, which means now my H value is 0.001. And when I did that, I got 128.016. Are you sure you want the post? What do you notice as I get closer and closer to 4? What's happening to the H value? Keeps getting smaller. This is getting closer and closer to 0. Do you think if I picked 4.000000001, this number is going to change very much? No, it's going to stay about the same, which is one way that you can approximate instantaneous speed, is you can just pick values close to it and you start approaching a number. So by looking at this chart, we could say that at time equals 4 seconds, it seems like that the speed is going to be about what? 128 feet per second. Making a table like that every time doesn't sound like that much fun to me, though, right? Especially because on the AP test, they're not going to give you a calculator to do such things because they're going to want you to do it algebraically. So, I know you might have run out of room on this, but if you turn the page, the only thing left on the next page is the assignment, and we could do the algebraically part on that page. So let me show you how we can say, instead of just looking at a table, let's take this idea of average speed and this t plus h, and let me show you how algebraically we can show that it really does work. So we're looking, in all of these, we took the value of t plus h at f, so we could write that as f of t plus h. Right, that's what we put here every time. And then we subtracted the value at the time, which we'll replace with 4 in a minute. And then on the bottom, every time, we just took the value of t plus h and subtracted the value of t. So we could write that as t plus h minus h. So that's the same as our average velocity formula, except for instead of just putting the numbers in, we just wrote it as that time of t plus h and time t. Since we know we're looking at time equals 4, we could leave just t in here. It's going to work out the same way. Plug in t later. But we could go ahead and plug 4 in here if you want. So let's look at f of 4 plus h minus f of 4 over 4 plus h minus 4. And what we're wanting to happen, and if you watch that video, they talked about secant lines versus tangent lines, and we'll talk a lot more about that in the coming days. But what we want to happen is when we pick those 2 points, when we pick 4 seconds and 5 seconds, they're like this far apart, and we average the speed. But then when we picked 4 and 4.1, they're a lot closer together. and then 4.01, and 4.001. And the closer that h gets to 0, the closer that they almost become the same point. And that's what we're trying to do, that instantaneous speed. So, first of all, we can do some algebra. This kind of seems scary at first, but it's not so bad. We know that f is 16t squared, because remember that was the original problem. Can I do f of 4 plus h? I can just replace t with 4 plus h, and that would just be 16 times 4 plus h squared minus f of 4. I'm just going to show my work on this one, but you can go ahead and work it out if you want, but I'm just going to say 16 times 4 squared. And on the bottom, 4 minus 4 is 0. Do you agree that I just get h on the bottom? I have a question or whatever. Okay, so now I'm going to do some algebra, because then we're going to talk about why am I doing this. But this is a good little reminder of algebra. 4 plus h squared is not just 16 plus h squared. You got to FOIL that out. So that would be 16 times 4 squared, which is 16, plus 4h, and 4h would be 8h in the middle, and then plus h squared. Right? I'm going to FOIL that out. So when I do minus 16 times 4 squared, that's minus 256 all over h. I'm going to go and distribute, see what I have here. So I have 256 plus 128h plus 16h squared minus 256. And you can see that these 256s are going to cancel out. So doing the algebra, I'm left with 128h plus 16h squared all over h. And all we've really done here is do some algebra, but what is h? H was that value we kept picking. So here's where this idea of a limit comes in. And tomorrow we'll talk, not tomorrow, because today's Friday. Monday we'll talk a lot more about the notation, but we want h to keep getting smaller and smaller so that those 2 points for average velocity keep getting closer and closer together, which means we want h to approach 0. So the way that we write that is we say the limit, you can write LAM, as h approaches 0. We'll talk a lot more about what that means on Monday. But basically, it means what happens as h gets closer and closer. And that chart showed us what's happening. Algebraically, if we can just plug 0 in here, then we can see what happens. But can I just plug 0 in for h right now? Because h is in the bottom. But then this is where algebra is helpful. Can I factor in h out on the top? If I factor in h out, I get 128 plus 16h. And those h's cancel out. So I'm left with 128 plus 16h. Could I now plug in 0 for h? Because if h was exactly 0, then it's the same point, right? Like it's no longer two separate points, it's the same point. So now if I plug 0 in there, look, we get the same answer that we got from our chart. 16 times 0, we get 128. And maybe you're like, I'd rather make the chart. But eventually we're going to do this a lot more. It's kind of just an introduction of one way that limits are helpful to us, because otherwise you couldn't find that instantaneous speed. Did you all finish that? Alright. So I have to. you to have to do this X plus of each thing, and there's not any like that on the online content. So, in your textbook, I want you to do number 2 and number 3 on the average velocity on this thing is. If you don't have your textbook with you, guess what? If your internet will work, I put the PDF copies of your textbook right here, and you're just doing number 2 and number 3. So you can, I don't know, you can't really write on this. You're probably going to need some paper. You know, you can type all that if you want. Put your X and all that stuff. I'm going to forever let you not be straight. Oh, you should get this done. The problem is for the numbers we did what? We did average velocity at 3 seconds. And maintenance velocity at 4 seconds. Your homework is average velocity at 4 seconds. So the great news is you have lots of time, so work on this, ask questions, measure things almost impossible. If you don't have your textbook, it's right here. Number 2. Oh. What? And then starting on Monday, like these exact types of questions, right? You can kind of look at those now. Those look kind of scary. They have those on the MathXL site, and so I'm probably going to assign you those off that. But I can print those out too. So if you would rather be a print person for problems, you can. The downside is on the print side, you don't get to check your answer and see if it's right. I like that feature because you know if it's right or wrong. Also, I've learned if you miss it 3 times in a row and you mark it wrong, you can just hit similar question, and if you get that right, it's going to be so you really have unlimited time to do it. You just have to then do it. If you're doing a business plan yesterday, and terrible at it, and they were like, okay, this is my 3rd try, like I have to get it right this time. And then it was annoying to me because it took extra 4 times in a row. And then one time I was like, that's not point, it's not. But then they were like, this is your time. The question again is still really what did you try? I have a really high goal that I'm going to put all of chapter 2 homework on MathXL this weekend. So like the whole assignment sheet, that will all be on MathXL. But that way if you want to work ahead, you can. But I know Kyler wants to. Oh my gosh, I'm still recording. You guys didn't help me remember.